This year, particularly the last 6 months, demand of computing has gone up substantially. And this is what's happened. Because AI went from simple one-shot answers to these reasoning and thinking AI, the results are so good.
China may have just changed the entire future of computing. A new analog chip developed by researchers in Beijing is showing performance numbers that beat some of the world's best digital GPUs, even though it uses older manufacturing technology the West never bothered to restrict. And this breakthrough arrives right as Nvidia's own CEO, Jensen Huang, warns that China is on track to win the AI race. So today, we're going to break down how this unexpected shift happened, why analog computing may be the next major leap in AI, and what it means for the global balance of power. And if the early data is right, we may be watching the start of a computing revolution the West is not prepared for. When Nvidia's leader predicted defeat. Every once in a while, something happens in technology that makes people stop and rethink what they thought they knew. It does not happen often, but when it does, it usually begins with a single moment. This time, that moment happened when Jensen Huang stood on the stage at the Financial Times AI Summit in London and said something no one expected to hear. In a calm voice, he explained that China is going to win the AI race, not in some far-off future, but on the path the world is already moving toward. Coming from most people, a comment like that would not mean very much. But Jensen Huang is the person who built one of the most important companies in modern technology, Nvidia, the company whose GPUs power almost every major AI model today. And it made people begin to think, what if the future of AI does not rely on Nvidia's digital chips at all? At first, the idea seemed strange. Nvidia is a giant in the AI world. The United States leads in advanced chip manufacturing, and since 2022, strict sanctions have blocked China from buying top-level processors like Nvidia's 100 and 800. To many people, that seemed like enough to keep China from catching up. But while the United States was limiting China's access to digital GPUs, something surprising was happening in their research labs. Chinese scientists began exploring a type of computing that most people believed was outdated and impossible to fix, called analog computing. And now, this dead technology has returned in a completely new way. So, if China has found a way to fix the problems that stopped analog computers in the past, then are we standing at the start of a new kind of computing era? As it turns out, China might not only be catching up in the AI race. It might have found a different path altogether, one that could change how AI, sixth-generation networks, and global computing power work in the future. If that is true, then the global balance in technology may be shifting in a way no one expected. To understand why this matters, we need to look back more than 100 years to a time before digital computers were invented. Before computers used zeros and ones, engineers worked with analog computers. The idea behind them was simple. Instead of breaking information into tiny digital bits, analog machines used smooth electrical signals to model real-world things like sound, heat, motion, and waves. For a short time, analog computers were useful. They helped with engineering, science, and military projects. They could solve certain kinds of math faster than the early digital machines. But they had one huge weakness. Analog signals were very sensitive to the world around them. They picked up noise, drifted over time, and changed when temperatures changed. A calculation that started out correct could slowly become wrong, and engineers could not fully control it. Digital computing eventually replaced analog because it did not have those problems. A digital transistor is either on or off. It is clear, clean, and steady. Digital chips became smaller, faster, and more powerful every decade. Soon, almost all computers used digital technology. For almost 100 years, scientists did not think analog computers could ever return. They seemed too unstable and too imprecise to compete with modern digital chips. But then the geopolitics changed everything. Since China could not get the most advanced digital chips, researchers began to explore ideas that Western companies had stopped thinking about. Instead of trying to follow the United States, they started looking for paths the rest of the world had ignored. That is when analog computing came back into view. Chinese researchers began asking whether the old problems of analog computing could be solved using modern tools. They wondered if new materials, new circuits, and new manufacturing methods could fix the issues that once made analog computers fail. At first, the idea sounded unlikely. After all, why would a technology abandoned for a century suddenly work? But the lack of high-end digital hardware gave China a reason to try. They had nothing to lose and everything to gain. And step by step, this pushed them into a place no one expected, the front of a new computing race. A path that once seemed like a dead end was suddenly opening into something bigger, and it is now at the center of what may become the next major shift in global technology. If China has truly solved the problems that made analog computing fail in the past, then we may be witnessing the early signs of a computing revolution, one that could change artificial intelligence, reshape communication networks, and alter the global balance of power. The entire future of AI may be about to change. And the first proof of that showed up in a single research paper, one we are about to open. Inside China's stunning analog breakthrough. To understand why this moment shocked so many people, we have to look at what happened next. In October 2025, a team of researchers at Peking University published a paper in Nature Electronics that caught almost everyone by surprise. It did not come from a giant tech company, a famous US lab, or a major chip maker. Instead, it came from a university team working on a problem most people believed was impossible to fix. Their paper described something simple on the surface, but world-changing underneath: precise and scalable analog computing, using RRAM, which stands for Resistive Random Access Memory. This was a new way of thinking about computation itself. To make sense of this, let's break it down one step at a time. Most computers today operate using digital computing, which breaks everything into zeros and ones. Your phone, your laptop, your game console, and almost every AI model in the world runs on this idea. But digital chips suffer from a limitation known as the von Neumann bottleneck. It means your data sits in one place and your calculations happen in another. This forces the chip to constantly move information back and forth between memory and the processor. That back and forth motion wastes time and burns huge amounts of energy. Now imagine if the memory and processor were the same physical thing. Imagine if the data never had to move at all. That is what RAM in memory computing does. Instead of storing data in one location and processing it somewhere else, RAM stores and processes information inside the same tiny cell. And this cell does not use a simple on-off binary system. Instead, it stores information as different resistance levels. The higher the resistance, the less current flows. The lower the resistance, the more current flows. A single cell can hold many different levels, not just two. If digital computing is like flipping a light switch on and off, then RAM is like using a dimmer switch with many steps in between. This allows the chip to perform huge numbers of math operations at the exact same time. It is naturally parallel and naturally fast, but here is where the breakthrough becomes almost unbelievable. The researchers at Peking University solved the problem that stopped analog computing for more than 100 years, the problem of precision. Their new chip reached 100,000 times more analog precision, 1,000 times the throughput of Nvidia's H100, 100 times better energy efficiency, and digital-grade accuracy equal to 24-bit fixed-point systems. And all of this was built using older commercial manufacturing nodes, the kind that the United States never bothered sanctioning because they seemed too simple to matter. The researchers tested their chip on matrix equation solving, one of the most important tasks in AI training, signal processing, and scientific computing. The results were a massive leap, and because the chip is made with older manufacturing technology, it can be produced at scale right now. For many scientists, the breakthrough felt almost unreal. Something that was supposed to be impossible, precision analog computing, was suddenly not only possible, but better than digital in speed and efficiency. Once this study came out, researchers, policymakers, and industry leaders began asking the same question. What happens now? There are two clear outcomes that could take place now. In this first future, the United States stays on the path it has followed for decades. American companies continue to scale digital GPUs, making them larger and more powerful. Each generation is built with smaller transistors, faster clocks, and more advanced architecture. But every improvement comes with a cost. The chips get hotter, they use more electricity, and they demand more cooling and more power infrastructure. Export controls continue blocking China from advanced GPUs, and the assumption remains that analog computing will stay an experimental idea, not a main tool. In this path, China keeps struggling with limited access to high-end digital hardware. But the United States also faces a challenge in this reality. Digital computing is reaching its physical limits, and the energy requirements for large AI models are rising every year. Data centers consume huge amounts of electricity, and national power grids already feel the strain. If this version of the future becomes real, then the United States might stay ahead for a while, but it will need to solve a growing energy problem. Digital dominance continues, but at a rising cost. On the other hand, the second future looks completely different. In this version, China does not try to match the United States in digital GPUs. Instead, it builds a new computing ecosystem around analog RRAM. The Beijing University chip becomes the first step toward a larger movement, one that changes how AI is trained, how signals move through networks, and even how devices think on their own. In this future, analog chips would make AI faster, save a lot of energy, and let devices like phones and cars run smart features on their own without needing the cloud. And here is the part that makes this path so disruptive. China gets several natural advantages. Electricity costs in China are lower, and the government gives large subsidies to tech companies. That means analog chips, which already use 100 times less power than digital GPUs, become even more efficient on Chinese infrastructure. Even more important, analog RRAM does not need the US-controlled parts of the global chip supply chain. It does not depend on Nvidia's architecture. In essence, it creates a completely separate computing world, one that the United States cannot easily block or influence. Right now, we do not know which path the world will take. It could be the familiar one, where digital GPUs continue to dominate. Or it could be the new one, where analog computing becomes the center of a different kind of AI revolution. If the second path is real, then this moment, this single paper from October 2025, may be the quiet beginning of a major shift. And the next step in this story is even more shocking. It hints at change in computing power that the United States may no longer be able to stop. The arms race about to begin. When people talk about the AI race, they often focus on powerful chips, huge data centers, and impressive models. But when we look closely, we discover that the AI race is really an energy race. Training a single large AI model can use more electricity than some small towns. Digital GPUs are strong, but they burn massive amounts of power and need huge cooling systems. They waste energy because they constantly move data between memory and processors. Analog chips do not have this problem. Instead of swallowing electricity like a large engine, they use only small amounts because their design allows them to compute inside the memory itself. It is this difference between heavy power use and light power use that explains why this breakthrough matters so much. China understands how important energy has become. Over the past several years, it has been building AI-ready power infrastructure faster than the United States. Entire technology zones have been designed with special grids for high-performance computing. Renewable energy projects are tied directly to AI hubs, and many provinces offer major electricity discounts to companies working on artificial intelligence. All of these steps show that China is preparing for a future where computing power will be just as important as natural resources were in earlier decades. Surprisingly, this transformation was pushed forward by the same sanctions that were supposed to slow China down. In 2022, the United States blocked sales of advanced chips like the A100 and H100, believing this would limit China's AI progress. But something unexpected happened instead. Much like Huawei did after it was cut off from American suppliers, Chinese companies began to invent around the restrictions. Huawei built its own operating system, its own chips, and even gained market share in telecom equipment. The same pattern is now unfolding in computing. By removing access to the best digital hardware, sanctions pushed China into exploring new technologies that Western companies were not investing in. While the United States continues to focus on digital GPUs, China is exploring analog computing, photonic computing, and neuromorphic computing at the same time. Analog computing uses resistance levels to process information. Photonic computing uses light instead of electricity. Neuromorphic computing tries to act like the human brain. Any one of these could change the future of AI. China's decision to explore all three gives it several chances to jump ahead. This is why the Beijing University breakthrough matters. It is not only a scientific result, it changes strategies across industries. The way semiconductors are designed could shift because analog chips follow completely different rules than digital ones. National power could shift as well because countries with more efficient computing gain an enormous advantage in AI. Military systems could change too, as faster and cheaper computation improves sensors, drones, and command tools. Even the timeline for AI development could shorten if analog chips can train models in days instead of months. When we put these pieces together, the picture becomes clear. The next stage of AI will not go to whoever makes the smallest transistor. It will go to whoever uses energy the most efficiently. And right now, China is moving quickly toward technologies that use far less power than digital GPUs can ever achieve. So what does this mean for the future? What happens if analog computing really scales up? Right now, China is not treating the analog breakthrough as a small research win. It sees it as the start of a whole new plan for future computing. Chinese researchers are already working on the next generation of analog chips. They want to build larger and more complete processors that can handle bigger AI workloads. They are also designing systems that can be placed directly inside telecom towers, AI data centers, and even military equipment. If China keeps moving at this pace, analog computing could spread quickly across its tech industry. It will probably show up first in telecommunications, because analog technology can control huge antenna arrays while using much less power than digital hardware. After that, it may move into AI training centers, since analog chips can handle matrix math much faster, which would cut down training time for big models. Finally, it could appear in defense, where low-power chips would let drones and sensors run longer without draining their batteries. The United States, meanwhile, faces a challenge. It does not have a major analog program being built right now. Most American companies are still focused on digital GPUs, making them smaller, faster, and more powerful. This approach worked for many years, but digital computing is now reaching its physical limits. At the same time, many US states are struggling to build the power systems needed to support huge AI centers. This makes the digital path harder to keep up. So, if China shapes the next generation of computing, what else does it shape? If China controls the architecture that trains the next wave of AI, then it also controls the direction AI takes. And if China controls AI, the balance of global power shifts in its favor. Some experts compare this moment to the rise of TSMC, the company that became the heart of the world's most advanced chip manufacturing. TSMC, which stands for Taiwan Semiconductor Manufacturing Company, builds the smallest and most powerful digital chips in the world. Almost every major technology company depends on it to produce their most advanced processors. Because so much of the global chip supply comes from this single company, it became one of the most important points of power in modern technology. But this new shift could be even bigger. TSMC controls how chips are manufactured, but analog computing changes what a chip even is. It is not about one company or one factory. It is about a complete change in how computing works. On one side, digital systems follow the old rules. On the other side, analog systems create a new set of rules. These two approaches could turn into two separate worlds of technology. The stakes are very high. Whoever leads the next computing paradigm will likely lead artificial intelligence in the 2030s, and whoever leads AI in the 2030s may shape global power for decades. The world could stay on the familiar digital path led by Western companies, or it could enter a new era built around analog computing, Chinese innovation, and a different idea of what computers should be. Thanks for watching. If you enjoyed this, don't forget to like, comment, and subscribe. Click the next video for more exciting content.